Right, welcome back everybody. Hopefully you had a chance to do a bit of networking there. So we'll go into our second session of the morning, which is titled, How Do We Ensure Urban Infrastructure is Resilient to Potential Threats? We've actually got 5 speakers. I'm the first. It's always nice to introduce yourself. And I'll go through the bio of each presenter as they take the stand. So the first talk is by myself. Just to give you a bit of background, my name's Gavin Jones. I work for the Building Research Establishment, and I'm responsible for development and research in security and resilience at the BRE. I come from a policy background, originally an engineer. I've got quite a varied career. I've worked overseas and in the UK. So when you'll see it from my presentation, it's very much focused. It's quite security heavy. But I try to talk and introduce you to the issues that we face in terms of financing and incentivizing people to build resilience. So I'll use this. So. Okay. Thank you. Okay, so I'm going to be a bit cheeky in my presentation because there's a questions to start off, and I probably end up asking more questions than giving answers, but because I'm the chairman, I feel quite able to do that. So some of the issues I'd like to go through in today's presentation is, first of all, what do we mean by infrastructure resilience? It means many different things to many different people. Why is it important for us to kind of embrace this concept? What challenges do we face in building resilience and giving better outcomes for economies and societies of cities? What more can we do? Where are we failing? And how do we incentivize the private sector to do more? So in terms of our UK infrastructure, it's pretty expansive. This is taken from the UK government's infrastructure plan. And Frontier Economics in 2012 suggested that our infrastructure is worth about £790 billion in 2012. And over the next decade, we will basically invest a further £250 billion in that infrastructure. So the numbers are big. It's a big investment, and we need to protect that. In terms of the definition of resilience, this is kind of what I work to. It's what the Cabinet Office work to, and the BRE's Centre of Resilience uses or adopts as our definition for resilience. In terms of kind of a couple of the key things to take out of that definition is we are looking at a system level, as people mentioned this morning, systems of systems. And a key word that makes this subject area very different to business continuity and property protection is adaptation. So basically, we're not only looking to recover from incidents, should they happen, but we're also looking to build over time our adaptive capacities and be able to improve. So the next time something comes, we're better, capable to actually not face the same failures. Another important piece here, resilience implies an ability to maintain critical functions. I think it's really important to emphasize that we're not talking about the integrity of infrastructure. So we're not interested in, will it stand up or not? We're actually interested in the function that the infrastructure is actually providing. And there's a quote there from Sir David Nicholson, and which basically emphasizes the importance that society has expectations on us to be able to deliver services. It doesn't matter what causes a disruption to that services. If they lose it, they're going to be disappointed and they're going to have a view on it. So what do we include in the scope of resilience in terms of the hazards and threats to our national and city infrastructure? This slide is taken from the Rockefeller Foundation's work. They've got an initiative called 100 Resilient Cities, and they survey, as part of the application process, each of the cities to identify what the mayors of those cities believe to be the most important issues facing their cities now and into the future. So in terms of infrastructure shocks, which is very much incremental changes, so this is your high impact, low probability events, these are kind of issues that people are concerned with. Flooding was an issue identified by over 50% of all of the cities entering that programme. But obviously it's quite a breadth of issues that cities are having to deal with. The Rockefeller Foundation go a bit further than looking just at kind of shocks, and they're quite interested in chronic stresses that cities face. So that encapsulates issues like infrastructure aging, problems with affordable housing, and etc. So it's almost never-ending in terms of the scope of what you can put under this banner of resilience. So it's quite cross-cutting, and I think some of the cities have found it quite difficult who've entered that programme to actually limit the scope of the chief resilience officers that they've all been told to appoint, because these issues are issues that any mayor would be expected to deal with. You could imagine how a mayor's going to be quite concerned. I know George is here somewhere from Bristol, and he's a member of this network, that actually your chief resilience officer is kind of doing exactly the same job as you. You're trying to provide better services to your people, better quality of life, economic competitiveness, and so on. So why is it important? I think it's pretty obvious. Our infrastructure provides the foundation for economic prosperity and competitiveness in cities. And we have to ensure that we're able to deliver efficient and effective public services, regardless of the situation we find ourselves in. And increasingly, particularly with the use of digital technologies, people are and the media coverage that you get when you have disruptions, such as the flooding in Somerset, people are very intolerant of disruptions to their daily lives. So this is something that's high on the political agenda. Unfortunately, it tends to mean that the issue of the day gets the highest priority, whether it be flooding last year or whether there's a terrorist attack, suddenly security is highest on the agenda. But basically that's something that's kind of in human nature, I guess. So how do we measure how resilient we are? There are a whole range of measures used by different kind of stakeholders in this issue, used by different sectors. So the UK government in rail will have a public performance measure for looking at whether trains arrive on time and whether they've been cancelled. The NHS is interested in waiting times, the number of operations which are performed, and so on. So they have a whole range of kind of indicators. And often the people don't even realise they're talking about the same issue of resilience. All of these different measures, there's nothing wrong with them, but it's very difficult to compare between them, or get a common metric for resilience. So if you are using very many different ways of measuring resilience, it's quite difficult to understand what good looks like. And from one sector to another, and from one person's perspective to another, resilience varies considerably. I've put a graph here, which is of the rail performance measure, which I mentioned just a second ago. And basically, this is produced by Network Rail on an annual basis to look at the performance of our rail infrastructure. And basically what it does is it looks at the ability of the Network Rail and the train operating companies to deliver on their frequency of train services. Now, what's interesting about this when we talk about resilience is that measure, when there's a major disruption to infrastructure, whether that be flooding like we saw in Somerset, they have the ability in that measure to discount when you're unable to deliver certain services. So, for example, they'll change the timetable of the trains to be able to maintain their level of service. And that's just something that the government has agreed with them, as because these are economically regulated sector. They've said if you have a major flood, it's not fair for us to say you'd be able to do 3 trains an hour or whatever. So we'll now measure you on what you think you can deliver under those circumstances. Now, what that means is that suddenly, and this goes back, I think it's about 5 years in the history, you very rarely see a dramatic change in performance. So resilience is quite hard to actually get investment in, because the measure that they choose to use in the rail sector doesn't actually allow you to see the disruption that you get in the rail sector from flooding, from terrorism, etc. So it's quite interesting. The measures are not always appropriate when you're trying to seek investment. Ultimately, it doesn't matter how you measure resilience. Ultimately, what we're all trying to achieve is a reduced likelihood of failures, a reduced consequence when failure occurs, and reduced recovery times to failures. That's kind of what we're all trying to achieve. So what does that require from all of the parties involved? It requires a risk-based approach. I mentioned that it requires system-level thinking. And something that people often forget is how complex our infrastructure systems are in terms of dependencies and interdependencies. It's very hard for operating companies to understand, owners and operators, where their dependencies lie and how that will affect their ability to deliver services. And I think some of the work that we need to do and some of the work that the BRE are looking at the moment is how do you model and what tools can we develop to help owners and operators of infrastructure to understand their dependency on their supply chains and so on. So there are kind of 5. I talk about a cycle for risk management, which is basically at the heart of resilience, which is about prevention, protection, prepare, response, and recovery. That's very much the kind of the risk management cycle we use in security, and I think it's pretty appropriate across the board. The key thing that we need to ensure is that we get adequate investment for infrastructure resilience, and we have to have balance across all of these phases of risk management. So what challenges do we have in getting investment in resilience? One of the key things, I think, and this in itself can be described as a resilience challenge, is the issue of the growth that cities are facing at the moment. There's some stats here on this slide taken from the very recently published infrastructure plan for London. And the numbers on that left-hand side are pretty staggering in terms of the additional services, the growth that London will experience between now and 2050. And I think the point I'm trying to get across here is that there are other issues that cities are having to face on a day-to-day basis and dealing with future growth, as well as thinking about the resilience agenda. And I think often resilience, because it happens, the issue is over a much longer time frame, it gets put to the back of the political agenda. Another challenge in terms of infrastructure resilience is that 80% of our infrastructure actually resides in the private sector. You know, gone are the days when government used to own all of the water industry, electricity generation, telecoms, and so on. So that means you need to have the private sector buying into this concept of resilience, and they need to see a payback on their investment. I mean, what this means is that the majority of investment decisions, you basically have to show payback, and there's a number of issues, uncertainty, long payback times, and financial risk that these companies aren't willing to take on board. So who pays for resilience? As I mentioned, I'm an engineer by background, so I like to try and put things into an equation, and you can kind of argue that this wouldn't stack up if you just use this mathematically. But essentially what I'm trying to get at here is that people very much understood, or private industry much understood, the concept of business continuity. They understand how basically that pays back to their business. To be able to maintain the services of a company means that you can continue to charge your clients and get money in. So it pays back. Resilience goes a little bit further than that, because basically it involves a situation due to dependencies that you're paying for benefits that are received by other stakeholders. So for example, if I'm a telecoms operator and I have a very high level of reliability, it's you as the consumer or the emergency services, etc., that are benefiting from that provision of service. I don't necessarily see a payback on that. And that's especially true in areas such as the water industry, where the amount of money you can charge to a customer in the water industry is very much fixed by an economic regulator. So my interest as a private owner and operator of water infrastructure is to minimize my expenditure, because I've got a fixed income stream coming from customers. So what I don't want to do is spend a lot of money on this term here, which I've called corporate social responsibility. That's the bit that nobody wants to pay for, which is the bit where other people are benefiting from me investing in my infrastructure and making it more resilient. Some of the other challenges that we face in building infrastructure resilience is existing regulation. At the moment, the Cabinet Office in the UK government very much take the lead in terms of delivering the UK's resilience and civil contingencies capability. And the focus to date has very much been on response to incidents and recovery. Very little work has been done on actually, on a proactive basis, of ensuring infrastructure is designed and planned with resilience in mind. So basically, the work is happening too late in the life cycle of projects, so you're not getting the benefits of prevention and protection. We have some other issues in our infrastructure sectors. Some are regulated, some are not. So I mentioned those sectors such as telecoms, water, electricity, which because of the way the industries have a monopoly, they have to be regulated from an economic perspective. And interestingly, very often, the economic regulator is not the same regulator as the government lead on resilience. So you have a very competing agenda there, where the resilience parties appointed by the Cabinet Office are trying to push the resilience agenda, and and manage to obtain increased investment, but the economic regulator is trying to cap bills for the consumer's benefit. So they're fighting against each other, essentially. More challenges, not to be pessimistic, but existing standards very much focus on the integrity of infrastructure assets. So again, back to, for example, bridge standards, it's about does the bridge stand up in a certain set of conditions, whether that be wind loading, seismic loading, etc. They're not interested in the actual function of the asset. And various standards are used across the infrastructure sectors, ranging from design standards, network standards. Some people use event standards or service level agreements. All of those different methods of actually improving performance, it's very difficult to actually align those standards across different sectors. The next challenge is that of uncertainty, and previous speakers this morning talked about this issue in relation to climate change. And basically what I'm trying to get at here is that owners and operators are very unlikely to invest in resilience unless there's a very high level of certainty in basically the data that they're provided with and the future direction of climate and so on. Ways of dealing with this is basically ensuring that if we are developing and designing infrastructure, that we have trigger points essentially, where we're looking to ensure that basically as time goes on, maybe in 10-year increments, and we're looking and monitoring issues like climate change, that you're able to have built in the foundation for resilience, and then basically you're looking at the current trajectory of data and then actually respond to that. So what more can we do? I think the key things that came out of the PIT review looking at resilience was that the market should be left to its own devices where possible, and we should minimise regulation. We should be looking to obtain private investment on a voluntary basis, and where that can't be done, then we look at regulation to make up the shortfall. One area of research that I'm currently involved in is looking at potential for mandatory reporting by companies on their resilience capabilities. What this does, like in financial reporting, when companies report on previous performance but look forward in terms of whether they're operating on as a going concern financially, similar concepts of driving change by forcing them to report to their investors on how secure their investments are in the future from a resilience perspective might be a lever to ensure that these people invest more in that kind of longer time frame, the further horizons, than these companies would normally work on a return of investment of 3 or 5 years, for example. And then the other key thing is that we must make sure that the metrics we're using to measure performance are consistent and transparent. And again, that goes back to this issue here, that sometimes these truths are hidden in the way that we measure our performance. This is my last slide, which basically looks at how then do we get investment. I think one of the key things that if we're looking at a voluntary type basis is whether we could use a scheme such as BREEAM, which has been very successful in changing the approach to sustainability and monetizing sustainability for companies, whether we can look at a similar kind of model in resilience terms and actually getting a performance-based measure of resilience and then basically using voluntary certification to obtain financing from investors. Oh, sorry, and here's my divisive slide at the last one, which is basically, is resilience a good investment? And I think the key point is it depends who's paying, it depends on the particular attributes of the project and its context, it depends what risks you're having to deal with, it depends on the stakeholders' priorities in your project, and the quality of the solutions that you're able to deliver. All of those factors will determine whether you've actually made a good investment or not. Thank you very much. Right, okay, so on to our second speaker. Nanco Dolman specialises in urban water resilience at engineering and project management consultancy Royal Haskoning DHV. With degrees in both civil engineering and landscape design, Nanco is one of the leading experts in water-sensitive urban design approaches, specialising in the development of water-resilient designs. Nanco, over to you.
Thank you very much, Gavin. I'm happy to talk about urban water strategies and water-resilient design. I will illustrate that on 2 case studies, both in the USA. And okay, this one. Cities are facing challenges, and we already heard on the urbanization of a lot of cities. People are living more in cities than outside. Also, they're experiencing pressure in the sense of climate change. Sometimes also temperatures are dropping or rising. It's about moisture in the air. It's about shortage of water, like sinking of cities, as well as increasing of floodings. But at the same time, we are investing a lot of value and money in assets, in systems, in infrastructure, in networks. Think about electricity, power, food, water supply, waste, etc. And it was said by the UN that a lot of disasters in the world that affects cities are water-related, almost 90%. We already saw that in the diagram of the Rockefeller Foundation. Floodings, and the main thing mentioned by cities around the world. And it's not only floodings, but it's actually also shortage of water, like sinking of cities, like Jakarta. Jakarta is sinking at a much faster rate than the increase of sea level rise. And at the same time, water is not only something to fight against or to keep out or build a threshold for it, but it is also something to cherish or to work with, like an asset. And it is not all about, it is also water challenges or having climate change. It is about the people itself. It's about livability in those cities. The expansion of the cities, making them livable for everyone having a job, economic basis. It's about also dealing and thinking about the use of fossil and natural resources and having alternatives for that. It's about awareness. So the social resilience is also very important in urban livability. And as a civil engineering firm, we have the opportunity to get involved in a lot of those developing strategies, both in emerging economies and also in frontrunners like Singapore. And for today, because we only have a short time, I want to introduce you to our experience in New Orleans and New York. And both case studies and thinking about adaptive strategies are based on restoring natural balance within the urban imbalance. And they're following water-sensitive urban design. So water management, sensitive about people, awareness, urban design, like engineering and design integrated together. Often those strategies are a response to a disaster, and we can learn from experience, of course. Just showing this framework for the water-sensitive cities that shows the relationship between water in the urban environment, the built environment. At the bottom, you can see the relation of technical solutions, engineering solutions to dealing with water extremes in urban areas. On top of the diagram, it also addresses the relationship with social and politic drivers. So just want to show you this because it's also very important and already adopted by the World Bank and the Asian Development Bank. New Orleans and both New York City are what we call a drain city. So we have a sewer system, a drainage system that's actually covered, sometimes open canals, but it's a really civil engineering solution to a water challenge. In 2005, Hurricane Katrina hit New Orleans and it flooded the city. It was also very fatal in casualties. And the response was that they wanted to rebuild the levee system, adding also some storm surge barriers as well. But it was only focusing on having this operation in building investment only in thresholds, in making a fortress of the city. So they didn't look within the flood walls itself. And there is a lot of infrastructure within this flood wall. Think about water supply, energy supply, etc. And connect. So we thought together in a Dutch dialogue between the Netherlands and the US, between engineers and designers, governance, finance, that it was very important to show also in the US that cities can transit to a more water resilient and adaptive city of the future, a more blue and green city, like an eco-city. So we got the opportunity to make an urban water plan that also included green infrastructure, of course. This shows just making the fortress of New Orleans. We looked within the border of this levee system on dealing with precipitation, groundwater, and also the city itself, like all the impervious areas. This is very common. This is actually happening 4 or 5 times a year because of flash floodings, of the elevation differences in the city. This is also happening. In the dry period, it causes damage to infrastructure because of subsidence. And this is the relationship with water. We put it behind a wall, and it's actually, we just not benefit of any assets of the water in the city. So we developed a strategy based on the Living with Water principles from the Netherlands that actually looks at delay, store, and then, when necessary, discharge or drain the water. Looking at what assignments do we have in green and needed blue areas. Looking at solution in ecosystems, providing green infrastructure, and making an image of a more greener and blue city. This is just an introduction because the threshold building, the engineering solution next to the more green infrastructure sustainable solution, was next to each other, executed. This was happened in New York in the end of 2012. The biggest cost in damage was actually caused by the power failure. There's also a network and infrastructure. It was not the storm surge itself, because it lasted only a few hours, and because it is an island, it actually can discharge on the gravity flow. But this caused the major damage. And you can see this is the lower part of Manhattan, including the financial district. And the city responded, the national government responded, and there was a very historic speech by Mayor Bloomberg at that time, the former mayor of New York, and he said that a flood defense is not only a threshold or for defense against floodings, but it can also be of multiple use. It can also be additional program. And we have to live with water, so sometimes to let water in, give room for the water. So he also said enhance urban livability, to invest in green infrastructure. And this image shows the tidal wetlands of Coney Island. And we as a company, we got the opportunity to enter a design competition initiated by the Sandy Rebuild Task Force in Washington. And from 150 submissions, we were chosen in 10 teams, one of 10 teams, to make a proposal for the Sandy affected region. And we were focusing on the urban dense environments together with OMA, so that's the architect, our lead architect, and that's the Office for Metropolitan Architecture. And we developed a strategy that integrates both making flood defenses as well as addressing challenges and the enhancing of urban livability. And we did the proposal implementation for the case study of Hoboken. And the city of Hoboken is shown on this ancient painting, opposite of Manhattan. And from history, it was part of the river system. And of course, it is very vulnerable to both flash floodings from stormwater as well as fluvial floodings and coastal floodings. Just showing a picture of this is just after Sandy. And the water, because of the low-lying areas, the water can't go out under gravity flow, so it has to be pumped. You can see the fire station to the right. And what Mayor Don Zimmer said was very important, that you can fortify a single facility or a single infrastructural node or object, but it is something, when we fortify this fire station, the fire truck can't get out anymore. So we need a solution for the whole community. So it's about more than only facilities or single infrastructure. Just showing some images of the different parts of the strategy. So first the resist part. We looked at two locations. First is a location, this is an infrastructural node at the south of Hoboken, the Hoboken terminal, both rail, light rail, transit for ferry and the underground subway system. And the big challenge, of course, is here to create flood defense integrated in buildings and existing infrastructure. An additional program in recreation and commercial use. And to the north we have the park, and this gives us opportunity to create an elevated levee system that is integrated in the park, but also gives opportunity to create wetlands to treat water. Delay measures like green infrastructure citywide, making impervious areas more porous, creating greener areas in the city, extension of curbs, creating bioswales. Main part of the strategy is more room for the water within the city, making a linear park, green circuit, alongside the light rail, that can actually turn into an urban river during flash floodings. And finally, of course, we need an emergency escape, also dealing with overtopping of water, and eventually to drain the water back to the river, we need some wet weather discharge pumps. To develop this strategy, we used a lot of outreach tools. So to get to speak with the community, also talk with stakeholders. We developed a survey, we developed a simulation, we organized exhibitions, a brochure, and we got in touch with a lot of people, not only the community during community evenings, but we engaged stakeholders. And that turned out that resulted in almost 50 letters of support of other mayors, but also like the Water Board, the New Jersey Transit, etc., developers, all supporting this initiative and strategy. And finally, we were awarded one of the winners in the Rebuild by Design competition. And the project was awarded funding from federal government of $230 million. And next week, Tuesday, the United Nations will award Hoboken a certificate for a role model city in resilience for this strategy, as well as their program in resilience for the mayor, Don Zimmer. What we learned from this is that it comes down to what I call the triple A. So first, to know, to analyze what are the vulnerabilities within a city. What are the opportunities? To analyze who's involved, who's willing to pay for it. Then you can draw up a strategy like the aim, so the second A, goals and challenges. Is it planning? Is it engineering? Where are we going to deal with it? And finally, and that's the difficult part of getting this going and implemented, is to act. Who's going to pay for it? Money is an obstacle, but also politics are obstacles. And this is actually said very recently that there is a prediction for maybe a next financial crisis caused by water problems globally, but maybe also because all these climate change adaptation plans are not implemented or are very slowly in going into action. And of course, always the situations are tailored. So this is my final slide. What we see is that a lot of frameworks and adaptation strategies are present. Always an integrated approach is required. different areas bringing together, like engineering, design, but also governance and finance. And yes, we can build on case studies. We can have, we have to go beyond the theory. Let's start with a pilot, scaling up that to a demonstration project. Still, of course, a long way to go. And maybe one day, like Frontrunner Singapore, we can have this kind of urban areas. And this is a former canal, a concrete canal that actually only discharges the water. It's now turned in a park, and that can also stores the water for beneficial use. And all the concrete is recycled to use in the park like this way. And also bringing people more closely to the water and cherish it, because it is an asset. Thank you.
Thank you, Nanco. It's good to see some case studies and some real successes that your company have had. I'd like to introduce Phil Stride, who's the head of the Thames Tideway Tunnel. He has been working with Thames Water on the project for the last 7 years. He's a civil engineer and has a wealth of experience managing both wastewater and clean water projects. His role with Thames Tideway Tunnel has focused on leading the widely praised public consultation process and the development of the consent application process. This is the largest planning application ever submitted in the United Kingdom.
Right, good afternoon, everyone. I'll move on down. So my presentation is entitled The Benefits of Resilient Wastewater Infrastructure. In relation to infrastructure, there's nothing more fundamental infrastructure than wastewater infrastructure, I would suggest. And in terms of the presentation today, as you would imagine, given my job title, I'm going to look at this from a London perspective. The key things I just want to go through are some of the consequences of not having an inadequate wastewater infrastructure, what we're doing currently to deliver new wastewater infrastructure in London, how we're delivering that in a sustainable way for 22nd century London, and some of the wider benefits in terms of legacy, very similar to my colleague in terms of what we're doing in terms of providing wider benefits than just providing a sewer. Right, so I think the first thing I'd like to do is play a very short video. It's only a couple of minutes, but in much better than how I can describe. It looks at a few things. It gets a few points over. Some of the resilience in London's wastewater infrastructure that was provided by our predecessors, one man in particular. The problems we've got in terms of sewage pollution into the tidal River Thames right now, and how particularly the Thames Tideway Tunnel is part of the resilient solution to overcome this problem. So if I could ask my three presenters, Ed, Sam and Nanco, if they could just move along. I think you'd get more out of seeing this video if you could see it on the screen. If they could just move along to that end of the stage, I think it would come. You'd be able to see it a bit better. Sorry about that. Oh no, just sit at the end there. That's fine. That's great.
I hate to break it to you, but everything we eat has to go somewhere. Yeah, I'm talking about poo. The average person has to go what? Like 365 times a year? That adds up to around 140 kilos of poo, which is more than double what I weigh. And that's just one person. Every day, London's sewer system has to deal with 1.25 billion kilos of poo. Most of the sewage gets treated at places like this. But there's a problem. The sewer system beneath our feet was designed when our city had a population of 2 million people. I mean, that's still quite a lot, but nothing compared to now. So when it rains, the system overflows, which is not good. If you imagine 8 billion toilets flushing straight into the Thames. That's how much ends up in the river every year. It's disgusting. And it's happening right now, right under our noses. Like here, at Blackfriars Bridge, where sewage can pour into the river at a rate of 50,000 kilos a second. It's just plain wrong. I mean, come on! London's one of the most impressive cities in the world. So you think someone would be doing something about this? And someone is. The Thames Tideway tunnel is going to be 16 miles long and take 7 years to build. It's massive. But when it's done, it'll take your poo directly to the sewage works and keep it out of the river for the next 100 years or so. Which means a cleaner environment for all of us, including the fish. And as London keeps getting bigger, we'll be protected, which is good. Because we're the ones who have to live here!
Well, that young lady did a much better job describing what this is all about than I would have done. So hopefully you found that interesting. Just very, very quickly, because it's brilliant that we're positioned here, right next to the River Thames and right next to Westminster, where the Great Stink event happened. But looking at this slide here, prior to the 1860s, the consequence of not having a resilient wastewater infrastructure in London was that cholera and typhoid were rife in the capital. And in the outbreaks of cholera between 1832 and 1853, 31,000 people died. So just to give you some idea of what it would have been like around here 150 years ago. And it was Sir Joseph Bazalgette who built these interceptor sewers, which you can see on here, that basically intercepted the sewage, as it says, and took the sewage off to balancing tanks in East London. Now, the reason this is particularly important to just pick this up is that Bazalgette's interceptor sewers, one of which runs adjacent to the bottom of this building, still form the backbone of London's sewage system 150 years on. So if that's not building in resilience, I don't know what is. As the young lady said, there were 2 million people in London in 1860. He had the foresight to design for 4 million people, which London got to in 1910. And there are about 8 million people in London now. So it doesn't take a lot of imagination to understand that in times of rainfall particularly, a lot of sewage, the system can't cope in terms of capacity, and lots of sewage goes out into the river. Last year, 62 million tonnes in 1 year, which is a lot of sewage. I'll try to mention that in a moment. And that happens on average once a week. So there has been this problem for a while, and there was a study group set up to look into the problem and come up with potential solutions. And I think the key thing about this is they came up with 4 potential solutions. I won't read them out, you can read them. But certainly sustainable drainage systems was one of the solutions they looked at, and it is certainly something that Thames Water very much support as being part of the solution to London's drainage problems. Anyway, for a number of reasons, I haven't got time to go into them all now, but sustainable drainage systems on their own couldn't deal with the scale of the problem. It couldn't deal with the amount of the density of urbanisation in London and the underlying geology in terms of clay and saturated gravels didn't help either. So it would have been very expensive. It would have caused a massive amount of disruption. And that's why, in terms of intercept overflows, the chosen solution was this single tunnel option. It was the only solution that met the environmental standards set by the Environment Agency and the timescale set by government, and also one that provided a resilient solution for London into the 22nd century. So in terms of the solutions put forward, there were a number of solutions, basically because the sewage treatment works were overloaded and so were the sewers. The 5 sewage treatment works in London have been upgraded. The 5 of them are the ones listed on here, Beckton and Crossness being the 2 largest ones in East London. I just noticing we've got a bit of a formatting problem with some of the spelling, but you get the gist of it. There's also the Lead Tunnel that goes from Abbey Mills, very near the Olympic Park, through to Beckton Sewage Treatment Works. And the final part of the jigsaw is the Thames Tideway Tunnel. As the young lady said, 16 miles long, which goes from Acton in West London and joins up to the Lead Tunnel at Abbey Mills. In terms of the sewage treatment works upgrades, Thames have spent £675 million upgrading those 5 major works on the tidal river Thames, and that's about increasing the capacity so they treat more flow to a better standard, and also making sure that less stormwater is discharged from them into the river. The Lead Tunnel, which I was glad to see Gavin had some of our photographs in his presentation, so you might recognise the tunnel from this picture here. It's the largest project ever done in the UK water industry, largest contract ever awarded. It deals with the largest discharge point in terms of a combined sewer overflow, one that's been there since Sir Joseph Basil built it in 1860. It's just under 7 kilometres long, and it goes down to 75 metres below ground. So if you can imagine, it's the height of this building underground. So if you look out and see how high up we are, that tunnel will go down to that height underground. And it's 7.2 metres in diameter, and it will be in operation next year. In terms of the Thames Tideway Tunnel, the Thames Tideway Tunnel and the Lead Tunnel have been designed to be as resilient as absolutely possible, bearing in mind it's a major scheme. It's £4.2 billion, not as big as Crossrail, but in terms of water industry, the largest project for 150 years. So it's been designed to take on population growth, as Gavin pointed out, the London Infrastructure Plan 2050, the figures in there, and it's also taken on all the UK CIP climate change guidelines as to how rainfall is likely to occur over the next decades, and all that has been taken into account, and we've designed all the infrastructure in terms of the concrete to have a 120-year design life. So it's robust, and we feel it's significantly future-proofed. It's 7.2 metres in diameter, so if you can imagine 3 double-decker buses side by side, you'd get those in a 7.2 metre diameter tunnel. That's about as wide, slightly wider than this room. And just to give you some idea of the volume, if you stand at Beckton now and stand in that tunnel, the one that's shown on here, and can imagine these 3 double-decker buses side by side, when the Lead Tunnel has been built, when the Thames Tunnel is connected to the end of it, you would be able to walk from that point for 20 miles to Acton. So it gives you some idea of what 1.6 million cubic metres looks like, and that tunnel will be used on average once a week, and it will fill up entirely 7 times a year. So it gives you some idea of the scale of the problem that we've got to deal with, and we are currently negotiating with our tenderers, and the contracts are due to be let in the next 3 months, with work starting on site next year. Right, in terms of our approach to sustainability, it's very much part of our culture and an integral part of what we do. And as it says on here, we're committed to protecting the wider environment. Interestingly, in terms of what Sam said earlier, we jointly sponsored with Crossrail the feasibility study for Wallasey, and that's our preferred option in our tender documents. We sponsored it with the RSPB and Crossrail. So that's something we have done. We've adopted a holistic approach to sustainability, very much looking at all factors in relation to environment, social and economic. We've also, as to build another link, very much support the Tunnelling and Underground Construction Academy, and I've been on the industry advisory panel for 4 years. So we have worked closely with Crossrail in terms of best practice. We will work to minimise the carbon footprint of the project. That was very much what we set out as an objective in our development consent order that was very thoroughly examined last year. And we're very proud that we've signed up to the government-backed infrastructure carbon review. And we are developing initiatives to implement a carbon action plan as a part of our commitment to that review. We'll also, as our tender documents say we will do, work with contractors to report their carbon footprint, and there will be quarterly reviews to ensure progress. And we're also working at the moment with the supply chain to make sure that they drive down carbon reduction, and very much working with them about what innovations they can put in place to achieve that. And we're also very pleased to say that we're part of the development of the BREEAM infrastructure initiative to deliver environmental assessment method and rating system for infrastructure that we're a key part of with other major infrastructure projects. I think 3 of us. In terms of the wider benefits of the project, we've developed a detailed legacy strategy to outline how we can maximise opportunity for creating beneficial residual effects from the project. In terms of the ones shown on here, some of them are more obvious than not. Environment is the first one on here. Obviously, river water quality is something we'll significantly improve, as well as biodiversity in the river. In relation to health and safety, we're very keen to raise the bar in terms of health and safety performance in the UK for others to follow, and very much learn the lessons from Crossrail and the Olympics. In terms of the economy, we're very keen to improve the competitiveness and vitality for London. And in terms of really important that we're going to rejuvenate London's river economy. When we're in maximum production from the tunnelling, in terms of removing the excavated material, the freight traffic under London Bridge will be 3 times greater than it is now, just to give you some idea of scale. In terms of people, we're very keen to improve Londoners' enjoyment of the river, both in terms of recreation and travel, and we're very keen to inspire and upskill a generation. When the project's at its peak, there'll be 9,350 jobs created, which is a significant number of jobs. Also, we'll create 7 sites into the foreshore, so there'll be 3 acres of additional public realm where Londoners can go and enjoy the river. So, summing up this, there are lots of wider benefits. The Thames Tideway Tunnel isn't just a sewer, and there's a real opportunity to sort of reconnect London with the river. So my final slide, just summarising what I've gone through. Hopefully, I've outlined what happened when London didn't have a resilient wastewater infrastructure in place, how we're going to go about delivering new wastewater infrastructure for London. Some of it's underway, some of it's been done. The Thames Tideway Tunnel will start next year. How we're working to deliver that in a sustainable way, and outline some of the wider benefits. Okay, thank you very much.
Thank you, Phil. Right, we are running a bit behind schedule, so Ed, if you can stick to about 2 minutes, I think you've got left for yours. But Ed Parham is an Associate Director at Space Syntax, which provides strategic, evidence-based consulting services in economics, planning, design, transport, and property development. Space Syntax forecasts the effects of planning and design decisions on the movement and interaction of people in buildings and urban areas.
Thank you. Thanks. Okay, so I'm going to talk about space as infrastructure and how we can make urban infrastructure more resilient. Now, in terms of Gavin's presentation earlier, I think we're talking more about the long-term stresses than the short-term shocks. And really, the threats, I think, are things like when infrastructure networks are not coordinated, when they're not integrated together, then you end up with cities which are more difficult to move through, they're more congested, higher reliance on cars. They're more unhealthy, people that live there are more unhappy. You lose the benefits of a city. So we really want to avoid these things. Now, this isn't, I don't think anybody would think that was a good outcome of a city. People wouldn't intend to create a city which is difficult to use and people don't enjoy using. So it's an unintended consequence. Now, partly these are unintended because of the way that planning was carried out at a certain time. And there were approaches where the thing to do was to separate uses into single uses and to prioritise the movement of cars over almost everything else. But one of the other things that has happened in parallel, and thankfully we're moving away from that approach to planning, something else that has happened, or happened at the same time, was that the disciplines involved in planning cities became more defined. more sophisticated, and as they became more sophisticated, they started to develop tools that were very specific to that discipline. Now, one of the issues is we might have a different approach to planning, but if the tools that the disciplines are using are not integrated together, then you retain some of that silo effect. So one of the other things that I want to talk about is how we can actually, if we start to think about space as a fundamental infrastructure of the city, and if we start to model space, we can use that as a way of coordinating some of the other modelling approaches, using it to overcome some of the silos that exist between disciplines. So why should we start with space? Why is space a good starting point? Space is important for a number of reasons. It's the part of a city that people move through. It's where people bump into each other. It's where people interact and transact. Now, cities are big networks of spaces. Now, these networks we can model, we can analyze them, and sorry, I don't know why this is. It keeps skipping. We can model these networks of space. We can analyze them. We can see which bits are most connected, which bits are you most likely to have lots of people using. How does it work at different scales? Which bits are more useful for cars? Which bits are more useful for pedestrians? So we have a way of modelling and analysing networks of space. So why is that important? Well, that begins to have a series of other spin-offs. We know that if you start to look in cities, pedestrian movement starts to follow the hierarchy of streets. Better connected streets pick up more pedestrian movement at a certain scale. If you look at the way that a whole city is structured, again, the better connected streets will pick up more movement by car as well. You start to find that land uses will follow the better connected streets. So things like retail, you need to have customers walking past a shop. If you open a shop in the wrong place and you don't have customers, it goes out of business. So you find that land use also starts to follow the hierarchy of space within that network. Property values, crime, there's a whole range of other factors that start to follow the characteristics of the spatial network. So the spatial network is important for a number of reasons. The last reason why it's really important is it's not only influential, it's very difficult to change. There's a number of boundaries that are spatial in their nature. Property boundaries, administrative boundaries. There's also a whole load of infrastructure networks that follow the spatial network underneath. So if you want to start to change things, it's going to be difficult for a number of reasons. So really, we need to start to think about space as a core infrastructure of the city, which carries a number of other systems within it. Now, there's become, in the last few years, more and more data has become available within cities. And we have the spatial network, which we can start to work with. But there are times when we want to add extra bits into that. So we might be able to get a good picture of how a city's working just from looking at the spatial network. But there are times when that doesn't explain all of it. There is more and more data that has been spatialized or has been tagged and georeferenced, which we can start to feed into these models. But there's also, we've done quite a lot of work to start to spatialize other data sets. So we've started to take things like census data at the finest scale of granularity we can and start to attach it into specific spaces. So really what we're doing at a higher level is linking people to the places and each other and using their spatial network to do that. So now we're starting to look at cities not only using space as a kind of core infrastructure for how the city works, but also as this kind of core to the way of modeling and analysing cities, which can start to get over some of these kind of differences between disciplines. It means that you can now have conversations where you have a planner and an economist using the same model that you have looking at a spatial model of the city. So how do we use that in practice? I've got a couple of examples of two projects which show how these integrated models have been supporting the design process. Sorry, I don't know why this has happened on here. I think it's been resized or something. Now this is a typical project process going from beginning of where you get the brief from to testing the impact of is this solution working? Is it doing what we want it to do? Now the model that we've got, the integrated model, is supporting a number of these phases from analysing the city, why do the current problems happen, developing concepts, testing them, and then showing the impact of these concepts. Now we've got two large projects. They're very different scale, even though they're both large, and they're in very different contexts. One of them is to start to look at the projected growth across the UK cities over the next 20 years. So, and in parallel to that, So we're talking, on one hand, we're going to be talking about networks of cities, how they relate to each other, and how growth happens across those networks. At the same time as that, we're going to be looking at Jeddah in Saudi Arabia, which is forecast to grow by 3 million people over the next 20 years. So it's not just the networks of cities and how they fit together, but how the growth happens within those cities themselves. So the starting point for both of them is that there's a growth forecast for the 20 years, UK 6.3 million, Jeddah 3.2 million. What are the existing conditions? One of the growth provides not just a major issue to try to resolve, but it also gives you an opportunity to try to resolve some of the existing problems and some of the existing conditions. Now, even though we've got very different contexts, a lot of the problems between these two areas are very similar. There's problems about congestion, traffic, access to key services, provision of or access to energy and utilities networks. So although we've got one city which is growing very rapidly and is probably not as well established or isn't at the same point in its development as a number of UK cities, it's sharing a number of issues with the UK cities that we've got. Now the starting point was to build the UK. We've got a spatial model. We have a spatial model of Jeddah as well. In Jeddah, we were starting to look at, because it's at a particular point in its development, the spatial model won't explain all of the differences. So you might have subdivided areas which have not been developed. There are big differences in how the density is distributed across the city. So if we had a spatial model of Jeddah, it doesn't tell the whole story. So we started to add population and employment. Once we've got these models made, then we start to analyse how they work across a number of scales. So on the left, we've got the UK. This is taking it and looking at how well connected everywhere is at a regional scale. So if you connect everywhere to everywhere at 100 kilometres, the bits which are red are the best connected. If we go back one scale, this is looking at 10 kilometres, and you start to pick up, you can see more clearly how the individual cities or kind of groups of cities start to work. And if we go back to the smallest scale, this is picking up the kind of cores of the cities themselves. On the right-hand side, we've got the same thing zooming in, so we can see that if you're looking at Jeddah, the kind of local centres that you get, which are most intense spatial networks, are popping up here. As you move up through the scales, then you start to see that there's a different hierarchy emerges, and it moves on to these kind of more regular networks that pass through the city. Now, we started by profiling the UK cities and saying, okay, we've got this spatial model. We can see that they've got different characteristics at different scales, and what does that actually mean? Now, we found that there were relationships between the way that a city works, the way that it's connected regionally, the way that it's connected across the city itself, and the intensity of the city centre. Now, if you look at something like 10 kilometres, so you look at how well connected the city is across 10 kilometres, you get really strong relationships with population. If you start to look at how intense the spatial network is at a much smaller scale, so at a pedestrian scale where maybe it's a 15-minute walk, then you get a very strong relationship to the number of jobs that happen in that city. And we think that there's a relationship between the size of the city. It's almost that the 10 kilometres and the population is the catchment for the city centre. The city centre tells you how intensely and how often the people in the city will bump into each other and create these opportunities for employment and other transaction. Now in Jeddah, there's been a number of problems that you get across the city, and these problems are really the result of poorly coordinated planning and implementation. It's things like you have a major regional scale motorway network that cuts through the centre. It's not coordinated with density. It's not coordinated with employment. It's not coordinated with the local spatial networks that existed before. The result of that is that you get severance. Everybody becomes reliant not just on using cars, but on using the same roads. So it's adding to these kind of issues that we were talking about at the start of the session. So how do we get over that? The principle we've been working to is to try to match growth to the spatial conditions, and that applies to the city itself at the city level within its regional network of connections to other cities, as well as how intense the centre is. It also applies to whereabouts in the city. If you have all of these problems, whereabouts in the city are the best connected places, which not just by by the roads, but by public transport, which bits are most walkable, and where do these kind of opportunities exist? So, taking the example of the UK on the left, we have this graph which is showing on this axis, this is explaining how well connected the city is. On the left is population. The red line is the national average. What we can start to say is that cities which are below the line have got very good spatial infrastructure, but the population isn't as high as it could be. So we can start to identify some of the cities which have got the potential to grow, and they've got a level of infrastructure that could support a higher amount of population. And this is in terms of population and the kind of natural employment things. We're not at the moment looking at the other layers of infrastructure. Cities which are above the line are the ones where the population is actually out of proportion to the level of spatial infrastructure. So these cities have got other risks. So that might be that these are the cities which will become congested, they'll be more difficult to move through, and they have all of these problems associated with them. Now, in the city of Jeddah, we started to, again, run through this profiling. We can see where there are major developments proposed in future. We can see where there's a public transport network that's proposed. We can identify the points on that network which become best connected across a range of scales. And these are the points where we want to concentrate the growth. And that will be increases in density, increases in employment, but it will also be the provision of social infrastructure and facilities which are not very accessible at the moment. So on the left, this is what that process looks like in the UK. You take the cities, find the ones which are under the line, and find out the proportion of additional population they could support for their level of spatial density. On the right, we've got the example of Jeddah. We've got the major development, link it together by public transport. These are all of the potential locations that you could start to think about concentrating growth. And we started to analyse them, not just according to how well connected they are by car, but also how walkable they are at the moment, and also how developable they are and how easy they are to change. So we've not just ranked them according to how well connected they are, but we've also taken a data set on land use and vacant land and started to look at where are there more opportunities to develop things and change things quickly. What you end up with is a ranking of centres. Those centres then become the points where density is focused. So you end up with a series of points of density concentrated at points within the city which are better served by, you can get to other places more easily, they're already walkable, and they'll be supported by public transport as well. Now we can start to impact test these results to say, okay, what does the difference mean, either between kind of two different design options, or what's the impact on the existing city? Now, on the left we've got the UK, and this is just showing how the hierarchy of city size across the country would change. London stays the biggest, but there are a number of changes in the kind of next level of cities down. The point with I think the exercise about the growth scenarios is that these are developing scenarios which are intended to start conversations. It's not a kind of fully resolved answer by itself, but it's a starting point to develop things in a bit more detail and start to think about things in a different way. What we have on the right is showing how the implementation of the public transport and the centres will be on the people who live in Jeddah. So what we have is a map that shows the number of centres that are within 15 minutes of every house or every residential plot in the city. That will be access to employment, education, healthcare, open spaces. So it's really what difference does this make for the people who are living there at the moment. Now red areas, you can see other places where you've got a higher number of centres. The blue are the ones where you have fewer. Now we've been able to export this into Google Earth, which means that we can give it to stakeholders, we can forward it to people that can actually start to use it themselves. They can pan around, zoom in on the bits that they want to, see how it's going to change the city. But one of the other things which is really useful is to be able to take the results and to be able to present it in a more kind of numeric way. So this is something that some of the decision makers have found really useful, which is the comparison of different options and how it affects the city in different ways. And this has been really useful, particularly with working with maybe some of the decision makers who don't have a background in planning or who aren't familiar with some of the kind of aspects of the built environment that you kind of take for granted working within one of the disciplines. this has been really useful for showing to people to say, okay, we could build this option, but you find that the number of people who are within 15 minutes of a centre is far fewer than this one. And so it's really a good way of engaging both with stakeholders and decision makers. So I know earlier on, I think it was in John's session, we were talking about cities being very complicated systems of systems and possibly creating unintended consequences, which was also a starting point for this. I think that although it's true they are very complicated, I think you can start to put issues in terms of a hierarchy, and you can start to relate that to factors which are more or less influential. I think we know that space is very important in the way that cities work, and it seems to be a way of starting to influence the way that cities are planned, so looking at a design and knowing what the impact is going to be and how it's going to work, but also creating one of these possible links to start to bring disciplines together in a more close way so that they can work together more closely. And what that's aiming to do really, or what it should be trying to do, is integrate solutions across a range of scales to avoid these longer term stresses and negative impact of city growth or potential city growth. So, thank you.
Okay, right. We've got about 5 to 10 minutes, I guess, for questions. We're a bit behind. So does anybody want to ask any of the panel members a question, please?
A question for Ed, and really focusing on your UK model and analysis was where, if at all, does the whole question of economics fit into that spatial patterning? Are there presumptions there that you've made? Are you just taking at conventions, or you're looking at different interpretations of that? How does that relate to infrastructures and linkages between those and the patterns that come out of it? Okay. Does that make some sense?
Yeah, it does.
Yeah.
I guess the answer is we've just been correlating data. So we've been taking the spatial data and looking at what correlates with it. So in terms of assumptions about agglomeration economics, I don't think we've been making assumptions. We've just been seeing this is a spatial profile of a city. This is how intensely the city centre works. This is its kind of wider spatial catchment, and this is how it connects to the region. And we've been comparing that to numbers of jobs, amount of population, other things like GVA, affluence, a number of these factors. We haven't been actually building anything into the model that makes assumptions about these things.
Still building an evidence base
Yes.
before you move to the next step in terms of analysis and comparison of options.
Right.
Is that right?
It is, and
Yeah, okay.
and one of the findings we had was that the measure that has been very useful is the number of spaces within a radius of every other space. And we've been calling it spatial density. Initially, we talked about it as spatial agglomeration because it's really how close all these things are together and how densely packed it is. The reason we moved away from agglomeration is because it has too many economic implications that I'm not an economist and I don't completely understand all of these things, but spatial density is what the measure is that we're using.
Okay, thanks.
Any other questions?
I'll follow up here with Haskoning DHB. Last question again for all of you. It's a challenge I've got, and I'm hoping you've got the answers. You all made the case that infrastructures, while we seem to have set ourselves up for looking at them in silos individually, they need to be looked at in terms of planning in the context of the urban realm and all the other things. There seem to have been some interesting projects that have tried to deliver that. And what I'm hoping is perhaps if you can, if you can let me know what you feel is perhaps the number one lesson from your experience of actually trying to deliver multiple objective, multiple benefit type schemes within the context of individual infrastructure and the way we're siloed all the way from government and the industry.
Who'd like to pick that up?
Before I start, the number one lesson is probably to work with others. From an early stage, I think Crossrail took the view that it was a project which was going to be done with London rather than to London. It's harder work, of course, because you're not just working within your organisation, you're working outside your organisation with people from different work cultures and different disciplines. But I think the lesson from the urban realm work that Crossrail has done has shown that it pays off. Quite simply, that the project, the urban realm project, is 3 times as big as the one that Crossrail would deliver on its own.
Right. Shall I add to that? I think it's a very good question. I think it's interesting that there's a lot of infrastructure projects in London, particularly, that come under different planning regimes. The Thames Tideway Tunnel is a nationally significant infrastructure project, and we've obviously had to comply with the Planning Act 2008. But I think in all of that, I think the answer is to be, if we've learned anything, to be open, transparent, talk to people early on, listen to what they've got to say. There's an obligation on us to go through a rigorous consultation, which we did over a 30-month period, where we generally went out, I believe, at the right stage of project development, when we were very much developing our plans, and consulted with people and listened to what they had to say, and then we were able to change, and wherever we could, modify our plans. And that included, in our case, talking with other major infrastructure projects, talking with each of the 14 London boroughs we deal with, and obviously listening to them about what our plans were, what we intended to do in particular areas, and to make sure that we understood the accumulative effect of what we were doing, as well as our individual effect, and whether that be in terms of public realm, whether it be in terms of transport on the roads that was caused by our work. So I think the thing to do is be out there and talk to people early on, and listen to what they've got to say, and where you can change your plans.
I'd just like to add, from my own experience, I was working in Abu Dhabi in the UAE, dealing with issues around safety and security. It's quite a difficult topic to discuss in the Middle East. The locals there don't tend to like to have those discussions. But what I found quite useful is by not only about a consultation process, but actually if you're able to speak the same language as some of the other disciplines, so they clearly understand what it is you're trying to achieve. I found that I was coming from a security background, but the planners, the architects, the engineers, suddenly, once they understood what I was trying to do, they started to actually become part of the process and take over my job almost. They become really interested in how they can contribute to getting better outcomes. So, a lot of the work we were doing was actually just using better planning and design to get better security outcomes. So that process of working together and speaking the same language is really important. Should we go to the back there?
I just wanted to ask with regards to the environment, the natural environment is always a place in preventing flooding. So you've got trees and hedgerows, and you see in the city, the city's become pretty much a concrete jungle. And I just wanted to ask with regards to natural fibres, you've got in Africa, you've got in Asian countries materials like bamboo, which are not really looked at much. They're sort of quite down in the West. You've got other natural fibres that we've had a history in the UK in terms of hemp, And what place does that have, considering that cement at the end of the day is very carbon intensive compared to local fibres like hemp?
Nanco, do you want to pick that up?
For example, when looking at New Orleans, it's actually the delta area of a large catchment, the Mississippi catchment area, and this delta area was original swampy wetland area with cypress trees, etc. And there was a lot of erosion going on the last years, last decades, because of human influence, of course, and canalization of rivers. The same we can see in other countries like Thailand. And for instance, when there is deforestation, they build, because they have to grow in crops, the erosion will increase. And the runoff of rivers will also increase even more. And all these rivers are narrowing down to one small strip, so with no place anymore in the city. And what we looked at for the urban water plan for New Orleans was to bring in, because of the natural fibers, and there's already parts of wetlands are inside the hurricane protection system, but there was a lot of loss in original vegetation and trees, but the key resource that's needed for that restoration of ecology within cities, especially a city next to an ocean or coastal areas, is fresh water, and the main source is the Mississippi. So, and the Mississippi, of course, is a part of the whole U.S. Almost, so a third of the U.S. So all people living in cities to the north and next to this river has to deal with narrowing down the emissions, cherish the water in the river itself, and then, of course, use it, and not only drain it, because then it is like a dried sponge, or making it also like having too much water, restore it and use it for drier times. And it was already in the plan, but this is very hard to get this urban imbalance into a more natural balance. But this is really important, and trees are a main player in this story.
Yeah, I'm not talking about trees, I'm talking about industrial cannabis in Bamboo, which has got a reputation around the UK.
I think what we'll do with that one, if you two want to connect over lunch, because that's quite a detailed question, so I think it'd be that would be a good idea. Are there any more questions before we head for lunch? Go ahead.
Well, can I just ask you about, because I'm processing the tunnel, because clearly the problem that we've got isn't the sewage, it's the surface water in the system that's making it surcharge. So a big percentage of what's going down there isn't sewage, it's surface water. Because looking at the examples internationally, if you particularly take Philadelphia, where they have the same problems, it was about being prosecuted for the pollution of waters, they very much took the option of building a small tunnel and then going for sustainable drainage options, because that was the most cost-effective system that they could do. Philadelphia, they couldn't afford. That was a sewage treatment plant, slightly different. But the question I want to ask is, because at the moment we're not seeing, the sustainable drainage that Thames Water are doing is not even petty cash in terms of the impact it can have. The tunnel won't affect flooding resilience. So how much did you look at the optioneering between using sustainable drainage, because you can't do the whole situation clearly, and the tunnel option, so that we actually got multifunctional benefits and improvements to biodiversity, improvements to flooding, as well as dealing with the undoubted problem of sewage?
Okay. That's a very fair question. I think the first thing is that, in relation to the last part of your question, is that there was an awful lot of work done over 6 years. I mean, it's a very big topic to cover in 15 minutes, but in terms of that Thames Tideway Strategic Study Group, they took 6 years to come up with their conclusions, and they didn't only just look at each of the options independently, but also looked at a combination of effects as well. So I think we absolutely believe that sustainable drainage systems are part of the solution, and there's a whole debate about who's responsible for delivering them, who's responsible for maintaining them, and there's a lot of work that DEFRA are going through in terms of providing sort of strategy and policy in relation to that. But we do absolutely feel that it's part of the solution. I think the issue we have in London is, because of where we are, and the gentleman mentioned a minute ago about runoff and the like, and the fact that over many years we've been tarmacking and concreting over sort of lots of surfaces, whether it be front gardens or whatever, that's drastically reduced the natural drainage into the ground. So the runoff from the sewers has become greater and greater. But the real issue is the scale of the problem, which I tried to sort of convey in terms of how much runoff there actually is. So it's one of scale, And it's one of a city which is, particularly in some parts, very densely urbanised. And certainly, in terms of picking up your examples, it's interesting people quote Philadelphia, because Philadelphia have got a sort of blueprint about what they're going to do, and they're like sort of 5% along that journey. But if you look at some of the other cities in America which have gone through that whole journey, I would particularly point to places like Milwaukee, Portland particularly. And Portland probably is the most similar scheme. I know it's a much smaller city, but it's very similar in many ways to the issues in London. And interestingly, although they put lots of sustainable drainage systems in place, they incentivise people to disconnect their rainwater from their roofs to go in the sewage system, they still built 2 very large tunnels adjacent to the river, the West Side Tunnel and the East Side Tunnel. So I think there is which demonstrates, I think, that if you've got a situation in London with the scale that we've got, if you were going to tackle it in some sort of time frame, bearing in mind we're something like 11 years late in complying with the Urban Wastewater Treatment Directive, if you were to put sustainable drainage systems in London, it would take you probably 30 or 40 years. We estimate it would cost about £13 billion as opposed to £4 billion for the Thames Tideway Tunnel. And it would cause just massive disruption in London, because you would have to dig up many of the roads, if not the majority of the roads in London, to put it in place. So in terms of, it would take an awful long time, and it would take an awful lot of money. And even if you separated half of the rainwater from the sewage system currently, which is a fundamental problem because it's a combined system, I think the issue is that you wouldn't wish to start your journey from here, but over 200 or 300 years, London has developed a combined sewage system, and it would be very difficult to go back and untangle that. Which is indeed part of the problem. But if you tackled half of the rainfall that went into the sewers, you'd need an area 40 times the size of Hyde Park to deal with it. Hence, I was trying to convey what 1.6 million cubic metres looks like. So SUDS has got to be part of the solution, but it can't be the main part of the solution. And I still believe we need a Thames Tideway Tunnel as the primary means of dealing with this problem. Sorry, that's a long answer.
Great stuff. Okay, right. We'll draw the session to a close. If you do have any other questions, these guys will be out having lunch. So sorry we went over a bit. If we could be back here at 1:45 to start the next session, which will be chaired by Helen. Okay, thanks very much.